Hi, it's me. I love meteorology, but something that also fascinates me, and probably fascinates you if you clicked on this video, is space. Well, we've only done so many trips to the final frontier. There is still much more that we need to learn about the galaxy, but what we do know is pretty wild. Today, we're going to discuss the sun. However, I'll be making a video for each of the planets, the ones in our solar system, all the way out to the planets we may consider as backup plans for civilization after Earth. While that may sound like a far-off future, with the continued building of data centers, it might just be right around the corner that we have to flee. Regardless, let's talk about the heart of our solar system and the engine to life as we know it, the sun. Not technically a planet, but a star. While its excessive heat and radiation won't allow for life on the star itself, its gravitational pull and constant production of energy is what allows life as we know it to thrive. Humanity has been fascinated by the sun as early as our creation. From cave paintings to tarot cards, we've celebrated the sun for its warming rays and its repeated gift of daylight. Worship of the sun was central to early civilizations, such as ancient Egyptians, the Incas of South America, and the Aztecs of what is now Mexico. One of the first people to offer a scientific explanation for the sun was Greek philosopher Anaxagoras, who reasoned that the sun was a giant flaming ball of metal and that the moon reflected the light of the sun. While he wasn't wrong on that second observation, we're pretty certain today that the sun isn't a large flaming ball of metal. The sun, while not having a solid surface per se, does have layers. Onions! The core, the radiative zone, and the convection zone. The core is the central region where constant nuclear reactions consume hydrogen to form helium. These reactions release the energy that ultimately leaves the surface as visible light. The core of the sun is estimated to reach a scorching 27 million degrees Fahrenheit. So hot would be a little bit of an understatement. The radiative zone extends outward from the outer edge of the core to the base of the convection zone, characterized by the method of energy transport, radiation. And the convection zone is the outermost layer of the solar interior, where its motion is seen as granules and supergranules. In this region, energy is transported via boiling plasma, where heated gas rises to the surface, cools, and sinks back down. Think of a convection oven, but huge and constant. The sun's atmospheric layers include the photosphere, the chromosphere, and the corona. The photosphere is the visible layer of the sun. The chromosphere produces most of the ultraviolet light that leaves the sun, and is strangely hotter than the photosphere, despite being farther from the sun's quote-unquote surface. The outermost layer of the sun's atmosphere is the corona, meaning crown, and we can see it the easiest during solar eclipses. The corona continuously produces solar wind, a continual stream of protons and electrons that are released at speeds ranging from 250 miles per second to 500 miles per second. When solar winds reach Earth, it sends a flurry of charged particles into the magnetosphere and along Earth's magnetic field lines, towards the north and south poles. The interaction of these particles with Earth's atmosphere can produce the aurora borealis, most often seen above the polar regions. If solar winds are particularly strong, we can see the aurora in other regions of the world outside of the poles. Solar winds transport 1 million tons of matter into space every second. In addition to the constant streams of solar wind, the sun sometimes expulses massive quantities of those charged particles in one go. These events, known as coronal mass ejections, can trigger geomagnetic storms in the environment around Earth. But it can also wreak havoc with power grids, telecommunication networks, and satellites orbiting the planet. During these storms, astronauts on the International Space Station need to seek shelter, and all spacewalks are paused with sensitive satellites powered down until the radiation storm has passed. But solar winds from the sun don't just affect us. Solar winds sweep through the solar system far beyond the orbit of Pluto, forming a large bubble called the heliosphere. According to NASA, the heliosphere is shaped like a long windsock as it moves with the sun. The heliosphere acts as a protective shield, defending us against cosmic rays consisting of energetic particles that can damage living cells. Now, cosmic rays are generated outside of our solar system and blaze along at almost the speed of light. Without that protective bubble, these high-energy atom fragments would constantly bombard Earth. Heliophysicist Richard Marsden, in an ESA statement, says, "Without the heliosphere, life would certainly have evolved differently, and maybe not at all." While to us the sun is massive, truthfully, is a relatively average-sized star in comparison to many other stars in the galaxy. Some solar systems even have multiple suns. One of the suns on the constellation Orion, named Betelgeuse, a bright red supergiant star that is 700 times larger than the sun. Unfortunately, this star is nearing the end of its lifespan. Because Betelgeuse has exhausted most of its hydrogen core, it is expected to explode as a Type II supernova within the next 100,000 years. When this core collapse happens, the explosion will be so bright it could briefly outshine the moon, making the red star visible during the daytime. But because of the distance, this supernova will pose no threat to Earth. But I know you're all aware of the bad news. The sun will similarly run out of hydrogen and expand and implode into a red giant in 5 billion years. I know. No need to start panicking yet, though. While no amount of sunscreen will save us, I'm more fascinated to see what we'll evolve into if we do survive 5 billion years from now. Maybe we'll be long gone from the Earth by then, on a new planet with a younger star. Who knows? But for now, I'll leave you with one takeaway. Despite how fascinating the sun is, please do not stare at the sun. I am begging you, do not stare at the sun. Anyways, I'll see you with Mercury next time. Have fun, stay safe,